Good day everyone, and welcome you to Global Education Zone. And today I'll be giving you a complete guide to JAMB UTME Physics. So that was too much time, let's delve into the matter. So now basically, in the description of this video, I will add the topics I'm talking about today, and which you can be able to go further and further your knowledge on each of them. But this is like a guide, and I will not go very deep into each of the topic. Now basically, we'll have to start from measurement, scalars, and vector. Now measurement is basically the habit of, in science, physics begins with measurement, because you have to measure your quantities, you have to measure your observations. So, and measurement is very important. Then we have what we call units, fundamental units and fundamental quantities. I've talked about those in another video of this channel, but I will still skim through them. Now basically, unit is basically, the fundamental quantity is basically a unit, a quantity that it's independent of every other quantity and cannot be determined by the remaining quantities. Like those fundamental quantities are quantities like length, your mass, your time, your candela, or which is your unit of magnetic flux. Then we have luminosity, we have amount of substance, we have electric current. Now your length, the unit of your length is your meter, the unit of your time is your second, the unit of your mass is your kilogram, the unit of your magnetic flux is your Weber. Then your magnetic your luminosity is measured in candela. Then you have your amount of substance measured in mole. Then your the last one I talked about was electric current is measured in ampere. So, and those are just fundamental quantities. Then we have fundamental units. Fundamental units are the units accompanying the quantities, and those are just what I talked about. Fundamental units, they are unit, like the unit of length is the unit of length is meter. So, and those units, we have the standard units and system SI units are the standard units, system international units that are used to describe our and even express our answers. We have the length km, mks, which is meter, kilogram, and second. Kilogram. We have the centimeter, kilogram, and second, centimeter, gram, second. So those are just systems of measurements and units. Then we have instruments for measurements. Then instruments for measurements include your ruler, which is also known as your meter rule, and that is accurate to the nearest 0.1 centimeter. You have your calipers. Your vernier caliper is accurate to the nearest 0.01 centimeter. So your meter rule is accurate to 0.1 centimeter. Your caliper is accurate to 0.01 centimeter. Then your micrometer screw is accurate to 0.001 centimeter. So this, the more the zeros, the more the accuracy. And then we have what we call the precision, and precision is known as the number of sufficiently known standard digits. Then the precision of this one is basically the half of the reading accuracy. So basically precision or the precision and reading accuracy, they are related. So we have something like this: 0.05. When you divide 0.1 by 2, you have 0.05. That is the extent of error that can occur when you are measuring with this instrument. So just divide the reading accuracy by 2, you get the precision and the error, the amount of error. Then we have significant figures. The amount of significant figures is the amount of accurately known digits. That's also known as precision. So that's the amount of digits that are accurately known in the measurements. Then we have measurement of mass. Measurement of mass, we make use of the lever balance, and that lever balance, it's like a balance that helps us to measure how much mass, how much substance is in a body. That's the mass, and each substance has its mass, and the amount of mass in a substance is determined by its density. So then we will be talking about density in derived units. Derived units involves when you manipulate fundamental units, you get derived units. Derived units include force, work, power, density, volume, area, momentum, velocity, acceleration. Those are derived units. For example, for acceleration is given by velocity over time, and velocity is distance or displacement over time. So displacement over time, that's displacement per time square. So, and then you might be asked to calculate the dimension of this. The dimension is basically dimension is basically the fundamental quantity. So the fundamental quantity of dimension the dimension of displacement is length. Then dimension of time is second, of time is of second. Dimension of second is time. That's LT. Then when it's in the denominator is a power negative power. LT raised to power minus 2. That's the dimensions of acceleration and so on and so forth. So and when your dimension is equal in your left hand side and your right hand side, that means your equations are consistent. Then we have scalars and vectors. A scalar is basically a fundamental fundamental or derived quantity or unit that has only magnitude but no direction. Whereas a vector is a quantity that has both magnitude and direction. Examples of scalars are mass, volume, area, all those things that cannot be expressed in terms of direction, and even pressure. Pressure is a dimensionless. It's something that has no it has dimension but it has no direction. It has dimension but no direction. So so pressure is a directionless quantity. Then we have vectors. Vectors have dimensions, directions, and they have magnitude. Vectors include your momentum and such as your electric field. Electric field has direction. Electric force. Most of the time, forces have direction, and the forces that have direction are also known as non-contact force. So those forces have direction and they act in a particular direction. So then we have motion. Equations of motion. Motion is the movement of a body from one point to another, and then relative motion is the movement of a body when considered from a particular frame of reference. So in motion, scientists like Albert Einstein, they expounded on the concept of relative motion to set up theories like theory of relativity. So relative motion is actually something that is actually a modern physics concept. So then motion, we have equations of motion. We have the first equation of motion we're considering is V is equal to U plus AT. And this equation of motion is expressing that the velocity is equal to the velocity plus the acceleration times time. So then we have V square is equal to U square plus 2AS. So here your V is your final velocity, your U is your initial velocity, your acceleration is your acceleration into gravity or your acceleration of the body. Then we have your S, which is your distance traveled. Then last we have S is equal to UT plus half AT square. Then your T is also your time taken. Then there's a fourth equation which is also optional to add. We have your S is equal to V plus U over 2 and your T. And this is an equation that states that your distance is equal to the product of your average speed and your time. So your average speed is your final speed plus your initial speed over 2, then multiplied by your total time taken. So those are the four principal equations of motion you'll be dealing with in your secondary school physics and even in your JAMB examination. So always remember that. Then we have equilibrium of forces. Equilibrium of forces talks about the fact that there are different conditions for a body to be in equilibrium. Number one, if the body is at rest or is moving at constant velocity, then or if the body is not rotating at all or is rotating with a constant velocity. So if the body is at rest or it is moving at constant velocity, when the constant velocity is constant, that means your V minus U is 0, because when your V is equal to U, it implies constant velocity. Constant velocity is that velocity where there is no change in the velocity, and when there is no change in the velocity, your acceleration will be 0. So that means there is no force, because you know that force is equal to mass times acceleration. Force is equal to ma. That means if your A is 0, that means your force will be 0. That means there is no force acting on the body, and that is a condition for equilibrium. Then you have when in rotation, body can be in rotation when it is not rotating at all or when it is rotating at a constant velocity. So then we have those are the basic principles of equilibrium of forces. Then equilibrium of forces, we have what is called an equilibrium. An equilibrium is the third force that will balance the two forces. So and it is always in opposite direction to the resultant. And what's the resultant? A resultant is a third force is another force that can have the same effect in magnitude and direction of a group of forces. So it's just like when you have a combination of different people from different places and they come together to form one body. That's what kind of like a resultant. Whereas an equilibrium is kind of like the opposing force that keeps the resultant in balance. So an equilibrium has the same magnitude but an opposite direction to a resultant. So always remember that. Then another concept of equilibrium we're talking about is the law of flotation and equivalence principles. So equivalence principle states that when an object is immersed in a body of water, when you have a body of water like this and you have an object immersed in it, So this body experiences an upthrust on it, which is equal to the weight of the fluid displaced. And Archimedes principle can be tested with the Eureka tube, where we have a U tube where there's a link. So when the volume of water in the tube reaches this portion where it can pour out, when the Eureka tube is filled to the maximum volume, and then when an object is immersed in it, then the amount of fluid that flows out of the Eureka tube is the weight of the fluid, is the fluid displaced. So basically, in Archimedes principle, it says that the upthrust on an object is equal to the weight of the fluid that is displaced. So that upthrust is like a force that is opposing the object. You know that from now that is so far, if you've made it successfully from your SS1 to SS3, you would have noticed that in physics and even in general nature, there's no forces without an opposition, and that is in line with Newton's third law of motion, which says that action and reaction are equal and opposite. That means whenever an object comes on the inside water with a downward force, it is natural and expected that the body of water we express an equal and opposite force on it. So that means it's expressed an upward force, and that upward force is equal to the weight of the object of the fluid displaced. So that is Archimedes' principle. Then we have the law of flotation, which says that for an object to float in water, the upthrust must be equal to the weight of the object. So basically, the upthrust on an if an object is in water now, for that object to float in water, that means the upward force must be equal to the weight of the object, and the upthrust can be increased when you increase the area of the object in contact with the fluid. And basically, this happens with fluids like water and gases. So they exhibit upthrust on one another, and that is why you can even in chemistry you can easily extract hydrogen from the air, because hydrogen is less dense. So there's an upthrust that is expressed on hydrogen by the air, and that upthrust is a result of difference in pressure. So and even the upthrust in a liquid is as a result of difference in pressure, and the pressure that acts downwards of the fluid is greater than the pressure that acts upward the fluid. So that difference in pressure causes the force, because you know that in further analysis, when you get to SS3, you also realize that your work done is equal to pressure, volume, and G. So basically, this equation tells us that the work is also proportional to the pressure. So when your work is done, there's also pressure. There's a pressure difference. So this pressure is also known as the difference in pressure. Sorry, I mean PV. Your work is equal to the pressure times the volume. So whenever there's a pressure difference, there's always a work done, and whenever there's work done, there's a force behind the work. That is force work. Now next, and that leads me on to the next topic, which I'll talk about is work, energy, and power. So what's work? Work is basically the result when a force moves an object in a direction, and that direction is equal to the direction of the force. Basically, and work is done in the sense that if I push this board that I'm using to write on, and this board moves, when it moves, my work done is equal to the force I used to push, the product of the force, and then the distance moved by this board. But if this board doesn't move, if you push something that doesn't move, that means there's no work done, because there's no change in displacement, or there's no change in distance. So basically, work is a function of distance moved. Then we have energy. Energy is also known as work, and there are different types of energy. Energy is like the various forms of work. And then we have kinetic energy, energy due to motion. We have potential energy, energy due to by virtue of position. We have nuclear energy, we have solar energy due to the sun. So and energy can be converted from one form to another. We have chemical energy, which is converted to electrical energy in our batteries. We have different forms of energy, and presently electrical energy is kind of the most dominant and most applied energy in the world right now. So then we have power. Power is the rate of doing work. Power is the rate at which work is done. So and power is basically known as when you have work, the amount of work you do in a second is called your power, and the unit of your power is your watts. So and the unit of work is joules or Newton meter. The unit of power is your watts. So you need to understand the units of each of these quantities. That's why in physics you often start with quantities in your physics SS senior school course, because for each of the things you'll be talking about, you also need to know the quantities and the corresponding units. So next we'll talk about simple machines. In simple machines, it's also an application of work. And in simple machine, we have a simple equation which says that the efficiency of a machine is equal to the work output over work input times 100%. So and then this is involving every single machine you can think of, just as your levers, your gears, your inclined plane, And then for your inclined plane, your velocity ratio is given as 1 over sine theta. So and that sine theta is formed at the angle of elevation or angle of depression of the inclined plane. So basically, these are just formulas, some of the formulas principal formulas you use for your understanding simple machines. So we have different types of simple machines. We have levers, we have inclined planes, we have wheel and axles, we have wedges. An example of wedges and axe. Example of lever is your hammer. The hammer is kind of like a first class lever. Then your third class lever includes your wheelbarrow. Your second class lever includes your wheelbarrow. Your third class lever includes your knife and your nutcracker and all the rest. All these machines. So these are just machines that they are used to make work easier. And basically, the definition of machine is seen as any simple arrangement that helps us to apply a small force to produce a greater effect. So basically, a machine basically makes use of a small effort to push a greater load. So you use a small effort to affect on a greater load. So that's why you have what's called effort. Effort is the force applied. Then your load is the force you are trying to move. And that load has its own weight and has its own resistance, known as inertia. So inertia is the resistance that a load opposes or possesses to the force moving it. Then we have those on that machine. You can go in detail because most of the time you will need to understand the application of all these machines and the equations governing their application. Like for example, you have for your wheel and axle, you have your velocity ratio. Velocity ratio is equals to 2 pi r over the pitch. So you can also check your textbooks to go deeper, but this video is meant to be a general view of the whole syllabus and the various aspects you need to understand. Then we have elasticity. Elasticity, we'll talk about Hooke's law, right? Hooke's law says that the in an elastic substance, in an elastic material, the extension of the material is directly proportional to the applied force. So, and then what that means is that when you stretch a spring, the more force you apply, the more it stretches. So your force is directly proportional to your extension, or you have force is proportional to extension. And then you have a constant. Anytime something is proportional, you always have a constant. So your constant is force is equal to Ke, and that constant is known as your constant of proportionality. And then this equation is used to calculate the work done in a spring. And then the work done in a spring is given as W is equal to 1 over 2 Ke squared. And this K is the constant of proportionality. Then your E is your extension produced. So as I said earlier, your work is a function of your distance moved, and that your distance moved is basically a function of your extension of your spring. So elasticity is one of the most simplest topics you need to understand. And then though you must have some intricate calculations, but you can still understand it if you know the principle and the basic equations. Then we have hydrostatics. Hydrostatics involve the pressure, Pascal's pressure law. Pascal's pressure law says that in a fluid or in a water body or in a closed fluid, the pressure acts in all directions and it is equal in all directions. So the pressure acting on a closed fluid acts in all directions equally. So and as a result of that, as a result of Pascal's law, pressure does not have direction. So when you have forces, when you have two equally opposite forces, they are moving in opposite direction and they are equal, then there's no force on that body. When you have an upward force acting on the body and then you have an equal downward force you are on the body, there's a balance. For example, as I'm standing here, there's an upward, there's a downward force on my body on the ground, and that is constituting my weight, and then there's an upward force or resistance offered by the ground of my body, and because of that I can stand still. But if the force on my weight is greater than the force of the ground, there will be a motion, which means I will fall down. But that doesn't work because the ground has a lot of resistance. The ground has a lot of inertia. So inertia is the resistance the body possesses, and that inertia is because of the mass. So because of the fact that the ground has a lot of mass, which is much more greater than my mass, so I cannot fall, and because of that I can stand still as I am now. So basically in hydrostatics we also have the effect of forces and in fluids. But when the pressure acts in all directions equally, then there's no force. So then as a result of that, the pressure is distributed equally. But there are lots of pressure which says that, for example, in a particular level of a fluid, the pressure on that particular level is equal. So in any point on a particular level, the pressure is equal, and as a result of that, liquids of different volumes. Anytime you have liquids of different volumes, the pressure at a particular volume at a particular density, or sorry, at a particular length is equal to the pressure at a particular level. And then the higher the volume of the fluid, the higher the height, the more the pressure. So this, it's all ensconced in a relationship. P is equals to density times mass. That's sorry, density times volume times acceleration to the gravity. So your pressure is proportional to P yes, height. P So this rho is called the density. Your pressure is the product of your density with your height and then your acceleration to the gravity. So and then and this pressure is also can also be known as pressure difference. So and then when you are dealing with atmospheric pressure and pressure of another isolated body, the pressure difference, the work done is always the pressure of the system is always equal to the pressure of the atmosphere plus the density of the gas by the height or the column of the gas times the density and the acceleration due to gravity. So and those are just simple concepts you need to understand and equations that help you calculate in your JAMB physics. Then we have temperature and thermal expansion. So in temperature and thermal expansion, we have to talk about conversion from one temperature scale to another, and then we have the Celsius scale, we have the Fahrenheit scale. So and the Celsius scale and the Fahrenheit scale, they are related by an equation. The Fahrenheit scale and the Celsius scale are related. Then the Kelvin scale and the Celsius scale are related, because for example your Kelvin scale is equal to your Celsius scale, the reading of your Celsius scale plus 273. So and that's giving you your reading in Kelvin scale. So and this temperature scales, they are related and they have what is by way they are measured, and that results in thermometric substances. So for you to measure the temperature of a substance or of a body, you need to have a thermometric substance, and those thermometric substances include substances like mercury, alcohol, and so in some cases some other metals. So and when you involve metals, you often measure the resistance, and that is called a thermometric property. A thermometric substance is a substance which has a property known as a thermometric property that can be directly proportional or inverse proportional to the change in temperature. So basically, that thermometric substance, there's a property of the thermometric substance, let's call it T, and it's proportional to the change in temperature. So for example, if the thermometric property is resistance in a platinum wire, then when you make a thermometer of a platinum thermometer, then when you have a body of a particular temperature, there's a particular resistance that will be the resultant of that platinum. So when it comes near that body, it gives us a particular resistance. So you measure the resistance and then you'll be able to convert it to the temperature reading. And those are just principles of temperature and thermal expansions. Then we have heat and vapor. So and heat is also a function of temperature. The heat content of a substance is known as the product of the mass times the specific heat capacity times the change in temperature. So and those are just formulas. In the heat and vapor, in the study of heat and work done, you can relate the heat transferred with the work done. For example, when you have an electric heater that's heating a body of water, and then the heat of the electric heater is given, and you know that heat is a form of energy. So that heat is also known as Q, and that is given by the product of the current IVT. So in essence, you are saying IVT will be equals to MC theta. So and then you can as a result of this, you can solve for any unknown. So because of the fact that energy is converted from different forms to another, you can also use this to solve for any unknown in energy equations. So that is for heat and vapor. Then we have molecular theory and heat transfer. So heat transfer is also related to MC theta and IVT, conversion of heat from one body to another, like conversion from copper to water, from water to copper. So and in that transfer, you make a suitable assumption that there is no heat loss. So that means you must use a well-lag calorimeter when you are performing this experiment. So and because of that, you will be able to equate the heat gain with the heat loss. Then we have molecular theory. Under molecular theory, we have what we call kinetic theory and particle theory. But kinetic theory is basically deals with Brownian motion and other motion of objects due to their molecules. And molecular theory can be demonstrated by diffusion, osmosis, Brownian motion, and even many other subatomic phenomena that we observe. So and those are just explanations of all this molecular theory. And then we have particle theory, that the theory that matter is consist of particles. So in that particular theory, we also have it in diffusion osmosis, in Brownian motion. So in Brownian motion, it's basically deals with the random motion of particles or impurities in a fluid or medium. So and those are as a result of the forces acting on them. They are being pushed about by the molecules of that medium. So and as a result of that, particular theory and molecular theory, they are like related to each other. That whenever you have a particle, that particle is acted upon by a force, and those forces are random forces. So that means for particles to move around randomly, there must be a force, and that force is a random force. They don't have any particular direction. They occur in random, and that when it occurs in gases, it results in what is called a gas pressure. Then we have waves and sound. So for the study of waves and sound, I've made a series in a video on in my channel, and that video is on light waves. I've talked about light waves, the reflection of light waves, refraction of light waves, and I even talked about the angle of deviation and the minimum angle of deviation. So you can check those out in the videos of this channel. So moving on, we have dispersion of light. So those are also topics I've talked about in the video. You can check that out. We have electrostatics. Electrostatics deals on the forces that act when charges are not moving. So the electrostatics law is given by a Coulomb's law, which says that the electrostatic force is equal to the is directly proportional to the charge. So there's quantum proportionality known as 1 by 4 pi permittivity of free space, Q1 Q2 over R squared. So this says that the force acting on two static charges, is directly proportional to the product of the charges, and then inversely proportional to the distance between the charges. So that is also similar to gravitational. We say that G is equal to M1 M2 over R squared. So those forces, gravitational forces, electrostatic forces, and electromagnetic forces, they are all related to each other by equations. So you can check that in your physics books, because it will always come out in your JAMB examination. Then we have electrochemical effects. So in electrochemical effects, we'll talk about the electrochemical and electrolysis. And electrolysis also, we'll talk about that also in chemistry, which talks about the fact that electricity can be used to break down a chemical substance, and also a chemical substance can break down to produce electricity. So that's electrochemical effect. Then we have alternating current. Alternating current is basically the type of current that changes its magnitude and changes its direction as time goes on. But direct current does not change its magnitude and changing direction. So alternating current is like, of course, like a wave. In a particular video of this channel, I've talked about waves. So, but a wave is basically it's like a sinusoidal curve, and it has a sinusoidal behavior. So those waves, they are just like alternating current. So we'll talk about that basically in a particular video of this channel. Then also we have elementary atomic physics, and elementary atomic physics talks about the fact that we have atoms, we have properties of atoms, then we also have wave particle duality of matter, and every other properties of waves and particles. So matter consists of atoms, and those atoms exhibit wave properties, and they also exhibit particulate properties. So these are basically the general topics you'll be asked questions on in your JAMB UTME examination. So you can prepare completely on these topics, and I'll also in the description of this video I will insert the topics, so that you can also prepare for them adequately. And I wish you success in your examination. Thank you for watching. Please don't forget to like, share, and subscribe this video. I wish you good luck.